Hello, everyone. I'm Michael Lawless, Senior Principal Scientist at Simulations Plus. And in this video, I'm going to discuss ADMET Predictor Import in GPX. This is part of the GPX tutorial series. The ADMET Predictor module in GPX allows one to import mole, SDF, RDF, or SMILES files into the program. The 2D structure of the input molecule is used to predict chemical inputs like pKa, solubility, permeability, and microsomal clearance, among other properties. With this module, one can also input in vitro values. So if in vitro values such as log P or FASIV, etc., are in the input file, those can also be read in and used in simulations. Formulation parameters like dose and in vivo values such as oral bioavailability, Cmax, and AUC can also be imported with the records. So the first thing I'm going to do is create a new project. I'm going to give it a name AP5 and then browse to a directory and create a new folder so that these files that I create for the project will be saved in that folder. Now, I could create this from a template. What I'm not going to, I'm just going to create a blank project and then specify the dosing and physiology. Now, both of these need to be defined before you can import a molecule. So the formulations, I'm just going to create an IR tablet. And then for the dosing schedule, I'm going to add a 10 milligram tablet here. So I would click OK and then change the dose to 10 milligrams. And for the physiology, I'm just going to add a simple male 30-year-old physiology here. And that's the default. And then I'll go ahead and save the database and then click OK. Then I can come into the compounds view here and either click AP import from here, or I could click AP import for the modules over here. And I'm going to select the file. The first file type I'm going to import is a mole file, and I'm specifying this mole file here. In a mole file, I'll show the actual contents of the mole file here in this window. So a mole file contains only one molecule. There's a header line here which can be read in. I'll show how to read those from an SD file. This is basically a comment and something about the version number, etc. Then there's 31 atoms in this molecule and 34 bonds. So each atom is listed out and the 2D coordinates are specified here. And then the atom type, this is the bond information. And then we get down here, this is attributes. And these attributes can be read to GPX, and I'll show you how to do that. So when I come into the compounds, I've already selected the file here. And then we're going to use the dosing schedule I set up and the physiological schedule. Even though I didn't create a pair, it will import that and create the pair. So I'm going to create a physiologically based pharmacokinetic model. And then I'm just going to go down here to this advanced settings here. And for the compound name, I'm going to use the information in the file, which was this name field here. And then I would just scroll down to the bottom here and click the Start Import button. Now, when it starts to import, it gives you information about the compound. So this is the name that I selected, the mole file, the mole name. So this was the header in here, and then the predicted properties from ADMET Predictor 11. So that's importing the molecule. We can go up to the Compounds tab. We have the name here, and then we can look at the structure. It calculates the molecular formula, the molecular weight, and then from that calculates the diffusion coefficient. It also predicts the solubility. Again, all these are ADMET Predictor predictions, the pKa's, the octanol water, log P, and then log D versus pH profile, etc. Permeability, this is S plus PEF model in ADMET Predictor. And then we can just go into simulations, check for warnings. There shouldn't be any. We've read in everything. And then create the CP time curve. And then also a run is created with this simulation there. So I'll just go ahead and quickly save the database and move on to the next step. I want to mention that if we re-import that file, a new compound name will be created by appending a 1 to the current name. Okay, so now let's move on and import a SDF file, which can have multiple records in it. So I'm going to select a file called logp.sdf, and we'll take a quick look at it in Notepad. So here's the file logp.sdf. Here's a header line for the first record, and then one of the attributes is the experimental log p, 2.57 for the first record, 2.59, and then for the final one it's about 2.62. So you can just kind of remember that when we import that. So we've selected the file, and then if we scroll down here to the advanced settings for log p and change this to user data and experimental log p. So that's what I'll use for the log p. And then here, I'm going to change this to use default just to see what will happen or show you what will happen there. And then scroll down to the bottom and click Start Import. Again, you get the records. Let's go ahead and expand this, and then you get output for each one of the records read in. And note that it's reading the first line of each record and assigning that as the compound name. And then if we go to simulations, you'll see that there's simulations set up for each one of these. If we go to compounds, there'll be compound data. So let's look at this first record here and see the octanol water, 2.57. So those were all around that. Okay, now for the final example, I want to import a SMILES file. So again, I'll go back into the AP import, click on AP import, and select the file here. This will be called fdata.smi. And again, let's take a look at that in Notepad. So SMILES file is a nice compact format. So the SMILES string has to go in the first column. Then we can have various attributes here. So this is the identifier. We're going to import the dose and the observed oral bioavailability. And there's just 3 compounds here. So going back to GPX, we've specified the file. Again, use the same physiology. Then here we're going to come under the compound name and user data, and we'll do the identifier. For the log P, we would have to turn this off back to use predicted. And then if we scroll down here further, here's where we have the dose. I can click on use data and then specify the dose for each one of these, and then come down to the observed values. And the oral bioavailability, we'll do the user data, and then click the FB button, and then again go down to Start Import. And again, we'll get this information from the predictions here for these new compounds. Okay, so I'll close that panel, and then let's go back up to compounds, and now see we have warfarin, carbamazepine, and erythromycin, which these were all just read in. And we can go to simulations, and let's do one for just carbamazepine, and then check the warnings again, run the simulation, and you'll see for carbamazepine, if we go to the summary view, we have the predicted oral bioavailability 65, and then the observed oral bioavailability. Now if we go back into this runs panel here, so for each import it sets up a new run, but it adds all the structures to the first run. So we could just select all and it would run all the simulations for all the compounds we've imported. If we go to the second simulation, it's just got those highlighted. And then third one is final 3. So let's go ahead and run just this final 3 again. So we'll close the output settings and then just click the start button. So we'll run those in 3, and then here's the CP time curve, and we can look at the summary view that'll have the oral bioavailability and the observed bioavailability for each one of these. So then if we go into the dosing panel and look at the dosing schedules here, you'll see that each one of these, an individual record for the dosing schedule. So for the carbamazepine, it's a 200 milligram dose, erythromycin 250, and then warfarin, a 3 milligram tablet. That concludes the demonstration of ADMET Predictor Module in GastroPlus. Remember that it can be used to predict parameters for the input compound. One can also import in vitro experimental properties or in vivo PK properties. I'm Michael Lawless, and thanks for watching this video.